Hey guys, Kenna here. So today we're going to be taking a look at how can people slow climate change. After we've gone over the causes and effects of climate change, what is it that we as humans can do to go ahead and try and change the direction that we're headed? Okay, so let's jump right in and take a look at our essential questions for today. Number one, how can people slow climate change? Number two, why is dealing with climate change so difficult? Three, what are the key tipping points in climate change? And four, how did human actions reverse the depletion of the ozone layer? I want to kind of give you a case study of an example where humans have been able to make the change and make a difference in what's been occurring on our planet so that you don't feel so overwhelmed or feeling like there's no hope, because there is. I strongly believe that there still is. Okay. But I also don't want you to underplay how important it is that we act, and not only act, but act now in terms of making those changes so that our planet is better and our species can go ahead and survive this major challenge that we're facing. I wanted to start you off with a quote, and I'll end you with a different one. Climate change is the greatest threat to our existence. In our short history on this planet, nobody's going to buy their way out of its effects. And that's Mark Ruffalo. And yes, he's an actor, but he's actually a big environmentalist and activist for the environment. And if anybody should know about threats, it's the Hulk, right? So let's go ahead and take a look at some of the evidence for rapid climate change. Just to kind of recap, before we start looking at some myths that are out there, because I think education is one of the best tools you can have to help combat problems like climate change. So let's look at that evidence for rapid climate change. Okay. The evidence for rapid climate change is compelling. And there are 9 what are identified as vital signs for the planet that I wanted to go ahead and highlight here. The first of these is global temperature rise. The planet's average surface temperature has risen about 2.12 degrees Fahrenheit or 1.18 degrees Celsius since the late 19th century, a change driven largely by the increased carbon dioxide emissions into the atmosphere and other human activities. Most of the warming occurred in the past 40 years, with 7 of the most recent years being the warmest in history, recorded history. The years 2016 and 2020 were tied for the warmest years on record. Okay. Also, we are dealing with a warming ocean. Now, the ocean, if you think about it, has absorbed much of the increased heat, with the top 100 meters, about 328 feet, of ocean showing warming of more than 0.6 degrees Fahrenheit since 1969. The Earth stores 90% of the extra energy in the oceans. Now, I want you to think about just how much energy it takes to boil a pot of water. You've probably remember the old saying, a washed pot never boils. Now make that pot an ocean. This is definitely an issue that we're going to have to combat. Number 3, shrinking ice sheets. The Greenland and Antarctic ice sheets have decreased in mass. Data from NASA's Gravity Recovery and Climate Experiment show Greenland lost an average of 279 billion tons of ice per year between 93 and 2019, while Antarctica lost about 148 billion tons of ice per year. It's a lot of lost ice. Okay, and we're not dealing with just ice sheets or warming oceans, but there are a lot of issues that we have to make sure we keep track of. Another is glacial retreat. So not only are we seeing our ice sheets shrink, but we're also seeing the glaciers move farther and farther inland away from their historic ranges. Okay, glaciers are retreating almost everywhere around the world, including the Alps, the Himalayas, the Andes, Rockies, Alaska, Africa, you name it, they're disappearing. I took my family to go ahead and see Glacier National Park, and it's getting harder and harder to see glaciers. The largest one, we didn't even make an attempt at Grinnell Glacier because it's a long hike for my young kids, but I hope to be able to see an intact glacier in my lifetime, and I'm just worried that the time is starting to run a little short on that. Okay. We can, however, very easily see decreased snow cover. Satellite observations reveal that the amount of spring snow cover in the northern hemisphere in particular has decreased over the past 5 decades, and the snow is melting earlier and earlier, which is scary when we start thinking of the drought conditions and what that does in terms of wildfire fire seasons, especially in areas like we have here in Eugene. And so we need to be careful that this snow melt, which is so crucial to our water that we utilize in terms of our rivers and our drinkable water sources, doesn't deplete to a dangerous level. And while we're seeing a decrease in snow cover, we're also seeing a rise in sea level. And that should make some sense. If we are melting ice that's on land, it's going to flow, either seep into the water table or flow down through rivers, lakes, and streams into our oceans and seas. Global sea level rose about 8 inches in the last century. The rate in the last 2 decades, however, is nearly double that of the last century and accelerating slightly every single year. In particular, examples like the Maldives just show how vulnerable certain cities are to this sea level rise. With more than 80% of its 1,190 coral islands standing less than a meter above sea level, the Maldives has the lowest terrain of any country in the world. And if we see the potential sea level rises that could be coming with climate change, these islands may no longer exist. They may be below water. So this makes the archipelago in the Indian Ocean particularly vulnerable to sea level rise. And so less glaciers, shrinking ice sheets, decreased snow cover, all leading to a sea level rise. And it's not just land ice that's melting. We're seeing a declining Arctic sea ice as well. This is both the extent and thickness of Arctic sea ice, which has declined rapidly over the last several decades. I'm talking decades, okay, not centuries, but decades. And because of these major changes in the hydrologic cycles of our planet, the how much ice is frozen, how much snow we're getting, how much rainfall, how much, we're also starting to see extreme weather events on the rise. The number of record high temperature events in the United States has been increasing, while the number of record low temperature events has been decreasing since the 1950s. The US has also witnessed an increase in the numbers of intense rainfall and major snowstorms. So when we do get it, sometimes they're really incredibly high. And especially in areas like the New England part of the United States, you may actually see some of the coldest and some of the heaviest snowstorms in history. Okay. I think there's one of the big things, and we'll talk about this as we hit the myths later on, that we start looking at. People just assume climate change means it's just everywhere is getting hotter all the time. We're not going to have any more cold. And in certain areas, like we have here in the Pacific Northwest, we are likely to see a lot less snow, a lot less cold weather, a lot more hot days. Doesn't mean they won't happen. And when they do happen, they'll probably be worse, but we're likely to see less. But when they happen, you could have some pretty major problems. Okay, these extreme weather events are a real issue. And as we start changing all of the amounts of seawater and ice and where it is and where it's going, we're actually going to see a changing in the chemical makeup of our oceans. Since the beginning of the Industrial Revolution, the acidity of the surface ocean waters has increased by about 30%. This increase is the result of humans emitting more carbon dioxide into the atmosphere and hence more being absorbed into our oceans. And the oceans have absorbed between 20 and 30% of the total carbon dioxide emissions from humans in recent decades. And that's about 7.2 to 10.8 billion metric tons per year. That's a lot of carbon dioxide. And maybe you remember from your high school biology days that when we start looking at carbon dioxide versus oxygen, we have chemical indicators that we can use to kind of measure this. Things like bromethymol, which looks at the pH of the water, and we definitely know that carbon dioxide is more acidic. Okay, so that's the evidence that's out there. Now, I think it's important that we try and address some of the myths that exist and talk about why those are sort of true or not true. because I think I see these floating around on social media, and we need to make sure that we aren't buying into the myths that are floating around out there that are not backed by scientific evidence. So let's look at our first myth. Number one, the Earth climate has always changed. Well, this is not really a myth. Yes, it has changed. And over the course of the Earth's 4.5 billion year history, the climate has changed quite a lot. And this is true. But the rapid warming that we're seeing now can't be explained by natural cycles of warming and cooling. The kind of changes that would normally happen over hundreds of thousands of years are happening in decades. Global temperatures are now at their highest since records began, since we started recording. In fact, 17 of the 18 warmest years on record have all taken place since 2001. This is much faster warming, and this corresponds with the levels of carbon dioxide in the atmosphere, which have been increasing since the Industrial Revolution. So when people talk about climate change today, they mean man-made climate change. And this is the warming of the Earth's average temperature as a result of human activities. Things like burning coal, oil, gas, your fossil fuels. These are the things that produce the energy for most of our homes, our national power grid. And this is what we use for transportation, that gasoline that you pump into your car, cutting down trees, limiting the ability to exchange that carbon dioxide out of the atmosphere, producing greenhouse gases through the foods that we eat. Remember, we talked about the impact of consuming meat. Now, I think it's important that we understand a little bit about how the climate has changed, why it has these fluctuations of warming and cooling. So I have a quick little video that's going to go, how does the climate system work? And then we'll look at the next myth.
The Earth's climate system is driven by two things: the way energy from the sun moves in and out of the atmosphere, and the way heat moves around the atmosphere and the oceans. Energy from the sun is the main driver for our climate system. When the energy from the sun reaches the atmosphere, some is absorbed and some is reflected, mainly from clouds. Most of the remaining energy heats the Earth's surface, although again a tiny fraction is reflected. The Earth's surface then loses its heat again through rising air currents, radiation, and the evaporation of water. Some of this heat passes straight through the atmosphere and back to space, but some is absorbed by greenhouse gases like carbon dioxide, water vapour, methane, and ozone. Most of the air, nitrogen and oxygen, doesn't do this. The atmosphere re-emits the absorbed heat. Some escapes to space, but some heats the Earth's surface again. Eventually, all the heat escapes into space, but not before the temperature of the Earth has been raised enough to allow us to survive. If the greenhouse gases didn't absorb and re-emit heat, we wouldn't be able to live on Earth. If nothing else happened in the Earth's climate system, weather and climate wouldn't change across the globe. However, the sun's energy is distributed unevenly across the globe. Because the Earth tilts, the sun's intensity changes at different latitudes and in different seasons. Generally, there is more heat near the equator than there is at the poles. In this example, the variation is shown during the northern hemisphere winter. To balance this inequality, the climate system moves heat from the equator to the poles through the atmosphere and the oceans. In the tropics, near the equator, thunderclouds develop, forcing warm air to rise and then drift towards the poles at high levels. Cooler air flows in the opposite direction at the Earth's surface, setting up cells. Similar cells develop in other areas as you move towards the poles. At the boundaries between these cells, air is either rising from the Earth's surface or falling down towards it. Where the air is rising, you will get low pressure, often with rain or snow. Where it's coming down, you will get high pressure and fine weather. That's how heat is moved around the atmosphere. Now let's see how it moves around the oceans. Changes in sea temperatures and saltiness create ocean currents. For example, the Gulf Stream is one of the strongest currents in the world. Surface water in the North Atlantic is cooled by winds from the Arctic. Cold, dense, salty water sinks and travels towards the equator deep in the ocean. In turn, the Gulf Stream moves warm water from the Gulf of Mexico northeastwards at the surface to replace it. This brings warmth to northwest Europe, making the climate milder than any other place at the same latitude. It is these interactions between the sun's energy and how the atmosphere and the oceans move heat around the Earth which produce different climates in different parts of the world and set up variations in our day-to-day weather. A warming world caused by increases in greenhouse gases could upset the delicate balance of our climate system and have an impact on our longer-term climate.
So the climate system is a pretty delicate thing, and we need to make sure that we keep our gas balance and heat transfer balance at a point where we can go ahead and get the protective qualities that we need to go ahead and keep our life going here on our planet. All right, so let's move on to myth number 2. Myth number 2 is plants need carbon dioxide. Again, plants do need carbon dioxide to live. This is not actually a myth, but plants and forests remove and store away huge amounts of carbon dioxide from the atmosphere each year. Here's the problem. There's only so much carbon dioxide they can absorb, and this amount is getting less and more, and as more and more forests are cut down across the world. This is largely to go ahead and grow crops for us, but these plants that we grow for food are not going to absorb as much of these greenhouse gases and much carbon dioxide as the trees will. So let's just be clear that CO2 itself does not cause the problem. It's part of the natural global ecosystem. Having carbon dioxide there is normal. It's the amount, the quantity of CO2 that's being produced by us humans burning fossil fuels and cutting down trees so that we can't reabsorb what we're emitting. And there hasn't been this level of CO2 in the atmosphere for 800,000 years. And so this is causing an unbalance in the system. And so we need to kind of keep that in mind as we go ahead and move through. Myth number 3, global warming is causing the Earth's average surface temperature to increase. This is not only making heat waves and droughts more likely, but it's also causing changes to our natural climate systems that we talked about a little while ago. These changes are making extreme weather events increasingly likely and more severe. For example, hurricanes and storms are becoming much more intense, moving slower and taking longer time to die down. Because of where we live, here in the Northwest, we are likely to get more rain and wind as a result of climate change, while New York will see a lot more snow. So it's not going to be hot everywhere all the time. That's not what it means by climate change. What we're talking about here is changes in normal weather patterns. Myth number 4. Climate change is a future problem. I don't know why people ever thought this was okay, but it's no longer a good excuse to act on climate change later, to push the burden onto future generations, our children, your children. Last year, the world's leading climate scientists warned that we have about 12 years to limit global warming to a maximum of 1.5 degrees Celsius to avoid a climate breakdown. We are already starting to see the devastating effects of climate change on global food supplies, increasing migration, conflict, disease, and global instability. And this is only going to get worse if we don't do something about it. Man-made climate change is the biggest environmental crisis of our time. It threatens the future of the planet that we depend on so much for our survival, and we are the last generation that can do something about it. Myth number 5, renewable energy is just a money-making scheme. For whatever reason, I hear this one a lot. It's a commonly held belief that renewable energy is really expensive. This simply isn't as true as it may have been in the past. Solar power and onshore wind are becoming the cheapest ways of generating electricity, meaning the energy they produce is cheaper than actually using nuclear, gas, or fossil fuels. Okay? One of the big problems we have here in the United States is, again, looking at this issue of subsidies. We falsely keep the price of fossil fuels lower than it actually is so that people keep buying it. But the cost of renewables has fallen faster than anyone could have predicted. And yet the governments are still backing dirty fossil fuels. We have some of the highest fossil fuel subsidies in the world. It's tons. That's what's making the cost cheaper for you. Myth number 6. Polar bear numbers are increasing. That's just flat out wrong. Climate change is the biggest threat faced by polar bears. The Arctic is warming roughly twice as fast as the rest of the world, causing sea ice to melt earlier and form later every year. And this makes it much more difficult for female polar bears to get onto land in late autumn to build their dens, and more difficult for them to get out to sea ice in spring to feed their cubs, which is their main source of prey, the sea, to raise their pups. This means that in some parts of the Arctic, polar bears are having to survive with less food than they did previously. Polar bear populations are predicted to decline by 30% by the middle of the century. Myth number 7. Renewable energy can only work when it's not cloudy or windy. Okay, it's dealing with wind, solar, right? Industry is developing new techniques for storing electricity and managing demand at peak times, meaning that even if the sun isn't shining or it's not blowing a gale, it's still possible to rely on renewable energy sources. The majority of US homes get their electricity from the national grid. When you switch to a cleaner supplier, they guarantee that for every unit of electricity you take off the grid, they'll put some amount of cleaner energy back in to help clean up our energy supply. Myth number 8. Animals will adapt to climate change. Well, again, like some of the others before, there's definitely some partial truth to this. This one's not really a myth. Darwin was absolutely right that adaptation happens. But let's be really clear about some things. Some plants and animals will adapt, but not all of them. To survive, plants and animals and birds confronted with climate change have two options. They have to move or to adapt. There are several examples of species, so many species that have moved to new habitats. But increasingly, it's a different story for many species. Given the speed of climate change, especially recently, it's becoming impossible for many species to adapt quickly enough to keep up with the changing environment. And as the habitats are destroyed by roads, cities, dams, etc., moving becomes an increasingly difficult task on its own, getting from one place to another because of humans. Okay, for those who can't move or adapt quickly enough, the future doesn't look very positive. Myth number 9. Okay. Getting rid of humans will fix this. I hear this one a lot too. This is really unreasonable and partially wrong. It's easy to start feeling that we've gone too far already. The planet won't be able to support the world's growing population. However, we can be a big part of the solution, just as we were a big part of the problem. The technology and systems we need to move to 100% renewable electricity by 2045 and use our planet's resources more sustainably are already available. What's now needed is for political and business leaders to take bold and urgent action towards using these solutions to address the climate crisis and restore nature. And one that I thought would be a good one to include, which just started kind of showing up, is China is the only country responsible for climate change. Despite being one of the largest emitters of greenhouse gases, China is also currently one of the largest investors in renewables. The increase in investment has been in response to the rapid growth of green business and the need to clean up air pollution in its major cities. If you've seen some of the pictures we've shown you, Beijing is a great example of really poor air quality, and so they're trying to fix that. But at the end of the line, climate change is a global issue, and we all have a responsibility to step up to the climate crisis. Action on it will need serious investment, but it has the potential to deliver huge benefits for both nature and for us. We all need to raise our voices and to fight for our planet. And the reason I think that this one has been on the rise more recently is that it seems to fit in with the rise in hate crimes against those of Asian descent since the start of the COVID pandemic. And it's just, it's not true. And if anybody's largely responsible for a bunch of this, it's the United States, not China. And we have not made the advances in renewable energy that many other places in the world are making. And so that's what we need to do if we're going to go ahead and make a change here. So the original question at the beginning was, how can people slow climate change? Well, if we cut waste and rely on new and renewable energy resources, we can reduce greenhouse gas emissions, save money, improve human health, and reduce the threat of climate change. So that doesn't seem that hard, right? Why is it then so difficult to deal with climate change? Well, part of it is it's a complex global and long-term problem politically. It involves the uneven distribution of both beneficial and harmful impacts of climate change. It involves the reduction of fossil fuels, which is controversial because there's a lot of money and power in the big oil industry, especially in the United States. The projected effects of climate change are not 100% certain. We don't know exactly where the cutoff point is. We know where we think it is. We know that humans have had a huge impact on the planet's climate. But is there a point of no return? Where is that point of no return? What's going to happen next? And the answer is we're not sure. So two key words I want to bring up here. One is mitigation. Mitigation means to attempt to reduce the severity of a problem and avoid harmful changes. So we want to be smart about the decisions we make and the changes we make for what the future is going to look like. We don't want to make changes that are going to actually cause problems to be worse. But if we don't do something, we may risk having major catastrophes be the ultimate outcome because we didn't change what we know is not working. And then adaptation. We as humans need to be adaptable. We can't be stuck in our ways and settle with what we're used to because the status quo isn't going to work anymore. And our planet is showing us that those things need to change. So what are the tipping points that they think we're looking for? What are we worried about that are the signs that this may no longer be recoverable? Number one, atmospheric carbon level is about 450 parts per million. If we hit that barrier, major concerns, red flags should go off. The melting of all the Arctic summer sea ice. We're not there, but we're definitely seeing a huge problem with this in decline. Collapse and melting of the Greenland ice sheets. Again, this is headed in the wrong direction. But there's still time. Massive release of methane from thawing Arctic permafrost and from the Arctic seafloor. Collapse of part of the Gulf Stream. If you remember the video we watched earlier, that's the strongest of the ocean currents carrying cooler water, warmer water up to the cooler regions in northwestern Europe. Severe ocean acidification. We're already seeing some of this with our coral reefs and phytoplankton populations beginning to collapse, and a sharp drop in the availability of oceans to absorb this carbon dioxide, leading to massive losses of coral reefs and ultimately severe shrinkage or collapse of the Amazon rainforest. So what is a tipping point? If you're not sure what I'm talking about here, this is a point where once we go over that bump, once that event triggers, we're going to see a really rapid decline in the overall health and quality of our planet. And so it's something we definitely need to be concerned about. Okay, so there it is, that list of tipping points. So we can slow climate change. We know we can. We can reduce greenhouse gas emissions, cut fossil fuel use, improve energy efficiency, shift towards renewable energy resources, reduce deforestation, and use more sustainable agriculture and forestry. And some countries, states, and cities, even private companies are working to reduce their carbon footprints. Some of these strategies include CCS, or carbon capture and storage. These are strategies to remove carbon dioxide from the atmosphere and store it in ways that aren't going to go ahead and harm the climate. Geoengineering, strategies intended to manipulate conditions to counter the greenhouse effect. Um, Trap less heat on our planet's surface, reflect more maybe out into space. What might that look like? This illustration shows some proposed CCS schemes for removing some of the carbon dioxide from smokestack emissions. In the process, we are looking from the atmosphere and storing it into the soil, putting it into plants, putting it into underground reserves and sediment beneath the ocean floor, capturing it so that it is no longer in the atmosphere, causing the problems associated with climate change. So these carbon capture and storage, or CCS projects, are intended to kind of do the opposite of what we've been doing. We dig up fossil fuels and we burn them, releasing the carbon into the atmosphere. Well, what if we capture that carbon and we resink it down into the ground? And that's really what we're trying to look at. So what can governments do? Well, there are several strategies. We can regulate CO2 and CH4, so carbon dioxide and methane. We can phase out coal burning power plants, which seem to be the biggest offenders. We can tax carbon dioxide and methane emissions, start some sort of energy tax, use cap and trade systems, phase out subsidies and tax breaks for fossil fuel industries and industrialized food production. Instead, maybe we could offer those subsidies for energy efficient technologies or cleaner energy solutions, and ultimately to increase development of alternative energy sources. That's going well, but what can you do, right? What can we do? Individually, we do have some options of what we can do to try and help out. First of all, again, get educated. The more you know, the better an advocate you will be for your planet. Then you can go ahead and start lobbying for your senators and representatives to go ahead and make changes at the political level. One of the things you can start looking at is to go ahead and calculate your carbon footprint. There's several websites you can go ahead and do this. Walk, bike, carpool, use mass transit. Try not to be the only one driving in a vehicle. Reduce your garbage by reducing consumption, recycling, and reusing as many items as possible. This is that reduce, reuse, recycle that you hear about all the time. Use energy efficient appliances and LED light bulbs. Wash your clothes in warm or cold water and then hang them up to dry rather than using your dryer. Close window curtains to keep the heat in or out. Okay, pulling down your curtains actually can do a lot to help insulate your house. So if you get the temperature cold, you can keep it that way by closing your blinds. Use a low flow shower head. Okay, less water usage, less in pumps, so there's less electricity involved, as well as lower water use. Eat less meat or no meat. You'd be surprised how much electricity meat uses to go ahead and ship and store. Okay, greenhouse gases for transport. Heavily insulate your house and seal all air leaks. You can lose a lot of air conditioning through that. There's one of the best things you can do in terms of keeping your house temperature constant is to go ahead and make sure that you have adequate insulation in both the walls and your ceilings. Use energy efficient windows. Newer double pane windows are much better at trapping heat in and out, so it keeps you warmer in the winter and cooler in the summer. Set your hot water heater lower, 49°C, 120 Fahrenheit. Okay, the hotter you keep it, the more energy it needs to keep it at that temperature. Plant trees. They help convert CO2 back into usable oxygen for us and sequester that carbon. Buy from businesses working to reduce their carbon footprint. Now, I know this can be a conversation which sometimes feels like, is there anything we can do to actually fix this? But we've actually shown historically that humans can make good decisions and make a difference. We had an issue with the hole in the ozone layer. I don't know if you guys remember that or not. It's still there, but it's definitely shrunk. How did people start to reverse the ozone depletion? So reduced ozone in the stratosphere coming from widespread use of certain chemicals, in particular chlorofluorocarbons, CFCs, was allowing more and more harmful UV radiation to reach the planet. By not producing and using ozone depleting chemicals and adhering to international treaties that banned these chemicals, we are currently reversing ozone depletion. Ozone thinning stems from the overuse of specifically CFCs, known as freons, used for coolants and air conditioning. Historically, they were also used as propellants for things like hairspray, if you remember Aquanet from the 80s. Ozone thinning allows more biologically damaging, this is that ionizing radiation we talked about, to reach Earth's surface, contributing to cataracts and skin cancer at higher rates than previous, and impairs and destroys phytoplankton, so aquatic ecosystems are largely disrupted by it. But the Montreal Protocol in 1987 and the Copenhagen Agreement in 1992 were big multinational environmental agreements that set goals to phase out CFCs and other ozone depleting chemicals. Ozone layer now showing signs of repair. Yes. Explain how countries, this is a great example of how countries working together to set goals and take action can reverse damage to our atmosphere. And so if we can do it with ozone depletion, it's a little more challenging with climate change because there are so many mitigating factors. But if we can make good goals and actually work towards those goals, I think it is very possible for humans to make the changes necessary to protect our planet. And I know we keep coming back to these, but one of the big things you can go ahead and do is take a look at your consumption of food. Okay. Our food produces 25% of all greenhouse gas emissions. Okay, so what are you willing to give up? What changes are you willing to make? Just like the animals in the wild, we as humans have to be adaptable. Okay, make the change. You can do it. As Senator Ocasio-Cortez says, we don't have time to sit on our hands as our planet burns. For younger people, climate change is bigger than election or re-election. It's life or death. Okay, stay healthy, stay safe, guys. I hope to see you soon. Take care of yourselves. So long.